Hello everyone, my name is Atish and topic of this learning video is largest eigenvalue and corresponding eigenvector. In this, we'll see if a matrix is given to you, how can you find out the largest eigenvalue and the corresponding eigenvector to it. And to find out this, we'll adopt a method named as iterative methods. So let us understand this. Let A be a square matrix of order n. As you know, if a matrix is of order n, how many eigenvalues it will be having? Certainly, n eigenvalues it will have. And these eigenvalues are distinct eigenvalues such that the absolute value of first eigenvalue is greater than the absolute value of second and so on is greater than the absolute value of lambda n. Okay, so let me highlight this. Okay, now to determine the largest eigenvalue lambda, namely lambda of A, numerically we follow the iterative method. Okay, and we know that if lambda is an eigenvalue and x is a corresponding eigenvector, then Ax is equal to lambda x. So what we need to do in this method, we need to start with the initial approximation. So let x0 be the initial approximation to the eigenvector x. Okay, then this equation x equal to lambda x will imply Ax0 is equal to lambda 1 x1, where what is this lambda 1? This lambda 1 is the first approximation to the largest eigenvalue, and this x1 will be the first approximation to the corresponding eigenvector. Okay, now moving forward, this is just for the first one. Now as this is an iterative method, so this process will get repeated. In the first, we have taken x0 as initial approximation. Now we have x1. So further this will imply Ax1 is equal to lambda 2 x2. Where what is this lambda 2? Where lambda 2 is the second approximation to what? Second approximation to the largest eigenvalue and what is x2? x2 is the corresponding eigenvector. Now you may arrive at a question that till when we have to continue finding out this ax1, ax2, ax3, ax4 and so on. So answer for that question is continue this process till xr minus 1 becomes negligible. Okay, for example, if you have some values in x1, say you got some value in x1. So suppose your x1 comes out to be say 1, and here it is say here it is 1 and here it is 0.2 and here is some eigenvalue. Okay, now using this x1 you have found out x2. So x2 is something like asterisk and then 1 0.2 001, for example this. So as you can see, the difference between this x2 and this x1 is negligible, because one difference is 0 and difference between this is 0.0001. Okay, so if such is the case, when the difference between xr and xr minus 1 becomes negligible, you can terminate the process. And terminate the process meaning thereby then the largest eigenvalue then the largest eigenvalue is lambda r, and the corresponding eigenvector is xr. Okay, so if this process is clear to you, let me take an example on that. But before that, let me tell you this about this method. This method, which we have called it as iterative method in the very beginning of this lecture, this method is also known as Rayleigh power method. So this is Rayleigh power method. Okay, so this is the name, another name of this method. So if this is clear to you, let us take an example on this. So the example will be like, so let us take an example. So the example is, you can take an example as say example number 1, and example says find the largest eigenvalue and eigenvector for the matrix. We have the matrix as minus 4 1 minus 5 2. So we have this matrix, and let us solve the problem for this matrix. So we have to find out the largest eigenvalue and the corresponding eigenvector for the largest eigenvalue. Okay, so let us start the solution of this. So it's a good practice to start with the given matrix. So let A is equal to, what is it? Minus 4 1 minus 5 2. So I have written this matrix. Now start with what? Start with the initial approximation. So you can write, let x0 be the initial approximation to eigenvector x. Okay, therefore what we can do, we can find out the values, or we can operate matrix on the vector x0. So what we have the matrix minus 4 1 minus 5 2 operating on, what is this x0? This x0, we have to remember this x0 is nothing but 1 0 transpose, and this be the initial approximation. Okay, so why I am taking 1 0? I am taking 1 0 because we have a 2 by 2 matrix. Okay, for a 3 by 3 matrix you can take 1 0 0. Okay, and so on. So now solve this. When you solve this, what you will be getting? Minus 4 into 1 minus 4, minus 5 into 0 0, 1 into 1 plus 2 into 0. So this is 1. Okay, now always remember that you have to make this position as 1. So to make this position 1, what I need to do is, I need to take minus 4 common. So minus 4 common, and we remain with 1 minus 0.25. 1 by 4 minus 1 by 4 is 0.25. Okay, and say this is to be lambda 1 x1. Do you remember what is this lambda 1? This lambda 1 is the first approximation to the largest eigenvalue lambda. Okay, now once you get this, so what is it? This is my lambda 1 and this is my x1. Okay, so once you get x1, now you can operate. What you can operate? You can operate matrix A on x1. So what is AX1? AX1 is nothing but minus 4, 1, minus 5, 2, operating on, what is it? Operating on 1 minus 0.25. Correct? Now just multiply minus 4 plus 1.25. So minus 4 plus 1.25. So this is minus 2.75. And this is 1 minus 0.5. So this is plus 0.5. Okay. Now again you have to make this position as 1. So what I can do is I can take minus 2.75 outside and it will remain like 1. And when you divide 0.5 by minus 0.25, what you will be getting? You will be getting minus 0.1818. Okay, and say this is to be lambda 2 x2, where what is this lambda 2? This, and what is x2? This vector. Okay, now I am going to find out again. Now you may be wondering why we are finding AX2 again, because if you can see the difference between these two is not negligible. So we have to continue the process till the values of this and this, the current one and the previous one, the difference between these two becomes negligible. Okay, so let us find out some more values, or like AX2. So AX2, what is AX2? AX2 is matrix minus 4, 1, minus 5, 2, operating on what vector we have? We have this vector 1 minus 0.1818. So when you solve this, what you'll be getting? Minus 4 plus 5 times of this. So when you do it, you'll be getting minus 3.091, and 1 ones are 1, minus 2 times this. So 1 minus this is 0.6364. Okay. Now what we have to do? Now you are smart enough to give answers. Like just take this as common. So when you take this as common, you'll be getting minus of 3.091, and we remain with 1. And when you divide this number by minus, so you'll be getting minus and some value, and that value you can find out with the help of calculator. Okay, so 3.091, so 2058 minus 0.2058. Now you can say this is to be lambda 3 x3. Lambda 3 x3. Okay, now go on finding the values, because difference between this and this is not negligible. So go on finding the values AX3. So what is AX3? AX3 is minus 4, 1, minus 5, 2, operating on, what is x3? This 1 minus 0.2058. So when you solve this, minus 4 minus 5, 1, 2, operating on 1 minus of 0.2058, you'll be getting 2.971, and here I will be getting 0.5884. Okay, 2.971, of course minus, and minus 0.5884. Okay, now take out this value common, so I will be getting minus 2.971. We remain with 1, and then when you divide this number by this, you will be getting minus, don't forget, right, minus 0.1980, and say this is to be your lambda 4 x4. Now again check, the difference between these two is not negligible. So again go on finding the values. Now let me give you one important remark that would be handy when you solve such type of problem. Have lots of patience to solve such type of problems. Okay, because if you make any small mistake, the number of iteration will increase. Okay, so you should be very precise with the calculations part. Okay, now let us find out AX4. So what is AX4? AX4 is -4 1 -5 2 operating on 1 minus 0.1980, and when you multiply this, -4 ones are -4 and -5 times of minus means +4, so you'll be getting what we'll be getting, -3.01, and here it is 0.604. Okay, then again you have to take this common, so this is -3.01 into 1, and this is 0. What you'll be getting? 0.2 some values 6. Okay, and this is lambda 5 x5. Okay, now after this again you can see the difference between this is not negligible, so again go on finding out the values. AX5, so what is AX5? AX5 is -4 1 -5 2 operating on, what is it, 1.2006. So this comes out to be, now again solve, make use of calculator. Okay, we'll be getting -2.997, and when you solve this, 1 minus 4, so this would be 0.6 something, 0.5988, approximately equal to. Okay, so again you have to take now this common, so -2.997, and we remain with 1, and the value when you divide this by -2.997, you'll be getting -0.1998. Okay, again not negligible, so you have to go on finding these values. Okay, lambda 6 x6. Now next what we have to find out? Next we have to find out AX6. So what is AX6? This is A -4 1 -5 2, then operating on x6, which is 1.1998, and when you solve this, you'll be getting -3.001, and here this is 1 minus 2 2s are 4, so this is 6.6. Is it 0.6004? Now take out -3.001 outside, you remain with, what is it, 1, and this is 0.2. Is it -3.001, and this is -0.2, and say this is lambda power 7 into x power 7. Okay, now again you can see the difference is not negligible. So again I am going to take one more value, say AX7. So when I find out AX7, so I just need to solve these values. So what values I will be getting now? So I am getting an advantage on writing on the board. So anyway, so when you solve this, -4 plus 1 minus 3, 1 minus 0.4 is plus 0.6, and then I will be taking -3 common, and I will remain with 1.2. Say this is to be 8. Now as you can see that the previous step 1 minus 0.02, and here also 1 minus 0.2. Okay, so as you can see the difference between two is negligible, or we can say that it comes out to be approximately equal to 0. So here the process terminates. Okay, and as the process terminates, so you can write here what you can write as the x x8 minus x7 becomes negligible, therefore the largest eigenvalue lambda is equal to, what is it, -3, and the corresponding what is it, corresponding eigenvector is x is equal to, what is it, 1.2 transpose. Okay, so this completes the problem here. So you can you can apply the same method to get the largest eigenvalue and largest eigenvector. And as we know that this is mathematics and we learn by doing, so we have a learning by doing activity, namely try this problem. Okay, so let me write down, try this at home. So example number 2, which says find the largest eigenvalue and the corresponding eigenvector for the matrix. Let me write down this matrix 4 1 1 3. So we have this matrix and you have to apply the same method to get the largest eigenvalue and eigenvector for this problem. Okay, so this is what we have in this learning video. I hope you must have enjoyed it. So thank you for watching this learning video. Thank you.